so this whole topic is we are working with area of rectangles. Now, what you hopefully already know about area of rectangles is that it equals length times width. And it doesn't really matter which side is the length and which side is the width, but if we want the area of a rectangle, we multiply this side times this side, or this side times this side. Doesn't matter. Okay, so here's what we know. The rectangle below has an area of 80 square feet, right? This is 80 square feet. That means there's 80 boxes that are a foot long. Okay, what's the longest side length? Include units in your answer. All right, here's the deal. We know that length times width equals area. So I'm going to start by multiplying. This times this equals this, right? This is going to be length times width equals area. Now, it doesn't matter which one's the length, which one's the width. When I multiply 2x times x plus 6 or x plus 6 times 2x, I like to write it like this. 2x, parentheses, x plus 6. Right? It would just look a little funny the other way. You can write it the other way. It doesn't really matter. Okay, equals, and the area was given to me, it's 80. Okay, now, I can actually see already this is going to be quadratic because when I multiply here, right, I'm going to get something squared. So, I'm going to go ahead and I'm going to multiply. I'm distributing. So 2x times x is 2x squared. 2x times 6 is plus 12x equals 80. Okay. Now, what I noticed right here is that this equation is not in standard form. So let's first go ahead and just subtract 80 from both sides. I want to make this side a 0. Right? This is how we solve. Okay. Equals 0. Okay, I now have a quadratic equation. Now listen, you can plug this into the quadratic formula. So if you want to pause the video right now and go ahead and use the quadratic formula, that's totally fine. It'll get you the same answer as what I'm going to get. But I look at this equation and I'm thinking, I think I might be able to factor this. So I'm going to factor. Now, quadratic formula, remember quadratic formula always works, always, so you can use it right here. Okay, but I'm going to say, you know what, I'm going to factor. I first notice there's a greatest common factor of 2. Next, I think, okay, now this is just a 1 here, so I need two numbers that multiply to 40, negative 40, and add to negative 6. So multiply to negative 40 and add to negative 6. This is going to be x. And x, I know I need a plus and a minus. Multiply to 40, and then I need two numbers that multiply to 40 and subtract to 6, and I'm thinking 10 and 4, right? Like 8 and 5, but those don't subtract 6. 10 and 4 is what I want. And because I wanted to add to negative 6, I'm going to make the 10 negative and the 4 positive. Oh, excuse me. This should have been, that should have been a positive 6 right there, right? I just made that up. That was negative. Oh, boy. Let's go back and fix it. Okay, so now I want them to add to positive 6, so I'm going to make this negative 4 and positive 10. Sorry about that. Okay, so now I have an equation that's factored, and look, this times this times this equals 0. So either 2 equals 0, which I know it does not, x minus 4 equals 0, or x plus 10 equals 0. Okay, so when I solve, I get that x could be equal to 4, or x could be equal to negative 10. Now here's what's cool about geometry. These numbers actually mean something, right? In algebra, I would just say, yep, x is equal to negative 10 or 4. But that's not what we're talking about here. Here we're talking about a rectangle. And here's the thing. See this negative 10? Let's plug x back in for a moment. Negative 10 plus 6 would be negative 4, right? That would make this side of the rectangle negative 4, and this side of the rectangle negative 20. Now, mathematically, look, that works, right? Negative 20 times negative 4 is 80. But can I have a side length that's negative 4 or negative 20? No, that's impossible. We can't have a length that's negative 4, right? What would that even look like? So what we do is we say, actually, this solution just doesn't work for our situation. Okay, it's called an extraneous solution. I am not confident that is spelled correctly, but it's basically just like an extra, right? Like, yes, technically, mathematically, it works, but for our geometry situation, it doesn't work. So let's try this 4. Look, x plus 6, that's 4 plus 6, that's 10. 2 times 4, that's 8. Look, that's 10 times 8. That is an area of 80. That's the solution I want to work with. Okay, so this is the one I'm going to move forward with. Now, it doesn't ask me what x is. It asks what's the longest side length. So we have one side, let's just call it the length, right? And it doesn't matter which is which. And the length is 2x. So that equals, so the length is 2x, right? Which I got just off the diagram. And so now we have x, that's 2 times 4, that's 8. And the width, which is just what we'll call the other side, and it doesn't matter, is, I'm getting it off the diagram, x plus 4, which equals, x plus 6. Oof, I'm struggling right now, folks. X plus 6, so that becomes, I'm plugging in 4, that becomes 4 plus 6, which is 10. Okay, now we're talking about, let's see, what are my units? I'm talking about feet, okay? And look what the question is saying. What's the longest side length? This one question's asking me what's the longest side length. Look, the next question asks me what's the shortest side length. The next question asks me what's the longest. This one says what's the shortest. So you just need to pay attention. But here I have 2 side lengths. One is 8 feet and one is 10 feet. And since this question asked me for the longest side length, my answer is, let's see, which one's longer? Oh, this one. So my answer is 10 feet.